Welcome back. This is an Aleks training video on using a phase diagram to find a phase transition temperature or pressure. I think this is easy. I think you'll think it's easy too. If you can just get past the fact that this picture looks weird and you're not sure what's going on. Remember, this is a phase diagram. Anything to the left of the first curve is a solid. And then as you move from the solid to the liquid, you're melting. If you move back to the left, you're freezing. Once you're a liquid, if you move across that second line, you're vaporizing or you're boiling. And then if you go backwards, you're condensing. At the bottom, you are that is going from directly from a solid to a gas. That's called subliming. If you have a very low temperature, okay, lower than the freezing point of water, say, let's take ice as an example. You put ice in the freezer, if it's lower than the freezing point, so if your freezer is lower than 0, which it is, you're going to lose some of your ice cubes. Like your ice cubes are going to shrink in the freezer because some of those molecules are going to have enough energy to go directly into steam, even in the freezer. And then if you leave those in the freezer a long time, you'll see that they just shrink down to nothing. Well, that's what's happening. It's called deposition when a gas goes directly to a solid. That's what frost is on the grass in the winter. It's a deposition. And then if you were to go from a solid straight to a gas, that would be why your ice cubes shrink. That's why, too, like on a cold day in February, it snows all a lot, and without it getting over freezing, most of the snow goes away. It's because it's going directly into a gas. All right, so the really simple question, they're saying it's 280 degrees Celsius, okay? Instantly I've got a red flag. Celsius doesn't make sense. I have to put everything in Kelvin. Everything is in Kelvin, okay? So 280 I'm going to have to add, if you'll remember, 273.15. Okay, so that's 553. All right, so 553, that's here. I've made a yellow line there, 553. Now, the temperature's along the bottom in Kelvin, and you can see Kelvin, and this is a trick. That's in Celsius, but this is in Kelvin, so you have to change it. And then, what's the pressure corresponding to that temperature? Well, it's where the point is, okay? So the point is you go up to the line, and then you do the point, you do the pressure point at that point as well. Okay, so you make a box. So how did I do it? I see that there are 4 boxes between 10 and 20. That means each box is 2.5. And that looks to me like about 60%. Okay, I'm just making a guess. Okay, so I just say 0.6 times 2.5. I get 1.5. So what is this? This is 12.5. 12.5 plus 1.5 is 14. So that's why I'm guessing 14. So it's going to be 14 atmospheres at 583 degrees. Okay. So since they gave it to you in Celsius, if you have to answer, I would answer in Celsius. But I think really all they said is find the pressure. So I would say the pressure is 14 atmospheres. That's all I'd say. Okay, great.